So this afternoon we're going to look at recurring and terminating decimals and their relationship to fractions. So let's have a look at what the words mean. So we've got recurring and terminating. So what those two words mean when they're related to a decimal are, it means it's talking about the numbers in the decimal places, what happens to them, whether they stop or not, or whether they carry on. So terminating decimals are decimals that when you have a fraction and you convert it to a decimal, it's 2 decimal places, or 3 decimal places, or 4 decimal places. It doesn't, and it can go on, but it doesn't go on and on and on and on and on. So, who can give me an example of a terminating decimal?
0.4.
0.4, absolutely. Another one. With 2 decimal places, maybe. 0.125, which is actually an eighth, isn't it?
Yep.
So if you convert an eighth into a decimal, it's 0.125. 0.5, 0.25, which is a quarter. Okay? So some fractions, when you turn them into decimals, are terminating decimals. It means that they sort of stop. Recurring decimals are decimals where one of the digits or more recur. That means that they occur again and again and again and again and again. Ad infinitum, so infinity. So who can give me an example of one of those? Yeah, that's right. So that's the classic one, isn't it? 0.3 recurring. Now the way we indicate that something is recurring is we put a little dot at the top. If, however, it's, say, 2 digits like that, 0.42, 42, 42, 42, 42, 42, we put a little line across the top, that's right. You might see it like this, 0.4, with a line like that, and that means 0.44444444, and it goes on forever. So this one, obviously, do you know which fraction is related to that?
1/3.
1/3, that's right. And obviously, if you look at the fraction, it means 1 divided by 3. So 3 into 1 doesn't go. So if we were going to do it by bus stop division, you know, 3 into 1 doesn't go, so you'd have to put a 0 in your decimal point. And then, of course, you'd have all the zeros. You'd carry the 1 across. 3 into 10 goes 3, remainder 1. 3 into 10 goes 3, remainder 1. 3 into 10 goes 3, remainder 1. And you could go on forever and ever because it would never change. So that's why we have this symbol to show that the 3 doesn't ever stop. Now, there is a way of telling whether or not a fraction is going to convert into a recurring or a terminating decimal. Okay, and I'm going to teach you how to do that. So, let's have a look at the fraction 3/20. 3/20. Now, that means 3 divided by 20. Okay? And of course, you could do it on a calculator and you would find out what the decimal was. But what I want to do now is we're going to predict whether or not it's a terminating decimal or a recurring decimal. So who thinks it might be terminating? Who thinks it might be recurring? Okay, let's have a look. Now the way you find out is by using the product of the prime factors. Ah, we've done that already, haven't we? So, product of the prime factors of the denominator, okay? The product of the prime factors of the denominator. So, let's do 20. Who can do the factor tree for 20 for me?
2 and 10.
2 and 10.
5 and 2.
5 and 2, okay? So the product of the prime factors of 3 over 20 is 3 over 2 times 2 times 5. Okay. Now, the rule is, if the product of the prime factors of the denominator only has a 2 or a 5, or combinations of 2s and 5s, combinations of the 2s and the 5s, it will be a terminating decimal. So this has obviously got 2 times 2 times 5, so it's only got 2s and 5s in it. So what does that tell us about 3/20? It's going to be terminating, that's right. It's going to be terminating. Now what I want you to do on your calculator, please, is just do 3 divided by 20. What is 3 divided by 20?
0.15.
0.15. 0.15. Terminating. Doesn't go on, it stops. Okay, so let's have a look at another fraction. I'll rub this out. So we're going to do 3 over 28. So we use the denominator and do a, no, don't do it on your calculator yet, because your calculator will tell you whether it's recurring or terminating. I want you to see, we're going to find out. So we need to do the factor tree of 28. Who can do that one for me?
2, 2 and 7.
2 and 14, and then 2 and 7, that's right. So you're absolutely right, Garrett, sorry. So it's 3 over 2 times 2 times 7. So what does that tell us? Is this going to be a terminating or a recurring decimal? It's going to be recurring. Because I've got a 7 in the product of the prime factors. Because the product of the prime factors of the denominator, it has to be 5 or 2, or 5s or 2s. Okay, only 5s or 2s. So it's going to be a recurring decimal. So do it now on your calculator. 3 divided by 28. Tyler.
0.1071428857.
Right, okay. And if we could carry on and on and on and on and on, we would have numbers that would repeat.
I don't know, my calculator doesn't turn sideways.
Cassidy.
Could you do another one of those?
We're going to do a few, yeah, don't worry. Don't panic. I have my sheet. Okay, so let's have a look. We're going to now do 7 over 40. So 7 over 40. So we need to decide whether or not we think it might be terminating or recurring. If you're not sure, the easiest way to do it is to do the product of the prime factors. So we do our factor tree. Who'd like to do the factor tree of 40 for me?
2 to 20.
2 to 20.
10 to 2.
2 to 10.
And 5 to 2.
And 2 to 5. That's right. Okay? So it's going to be 7 over the product of the prime factor, which is 2 times 2 times 2 times 5. So is it going to be recurring or terminating?
Terminating.
Terminating, that's right. I'll be back. It'll be back. Terminating. Actually, Terminator 2 was on the telly last night. Good film. Okay, so that's terminating. So what is it? Who's done it on their calculator? Maddie.
0.175.
Thank you. 0.175. Okay, stops there. Right, let's have a go at another one. Going to do 6 over 125. 6 over 125. So we need to do the factor tree of 125. Who'd like to do that one for me? Montana.
25 and 5.
25 and 5.
5.
5 and 5. Okay? So it's 6 over 5 times 5 times 5. Recurring or terminating? Terminating. Do it on your calculator then. Sorry?
0.048.
0.048. Okay. Right then. Just reading the last example. Oh, 71 over 120. Okay, let's try this one then. 71 over 120. 71 over 120. So, what's the product of the prime factors of 120?
6 and 20. Just
20 and 6, yeah.
and then for the 20 it'd be 5 and 4.
5 and 4.
And for the 4 it'd be 2 and 2.
2 and 3.
No, for the 4 it'd be 2 and 2.
2 and
yeah.
2. So we've got 5, 2, 2, 2 and 3. So 2 times 3 is 6, times 5 is 30, times, yeah, right. So it's 71 over 2 times 2 times 2 times 3 times 5. So is that going to be terminating or recurring? Recurring, because we've got that one in there, haven't we? So it's going to be recurring. Okay, so that's the easy way to find out whether fractions are going to be terminating or recurring. You look at the denominator, find the product of the prime factors, which we've done before, and see if they are only 2 and 5 or whether there's another one in there. Everyone okay with that? Okay, so what we're going to look at now then, that is to do with converting a fraction into a decimal. What we're going to look at now is converting the decimals into fractions, particularly recurring decimals into fractions. Matt, put your calculator down, please. Have you written these notes?
Yeah.
Good, okay. So, this one is trickier. So, we might need to do a few examples before you get the hang of it, because what we have to do when we convert a recurring decimal into a fraction is we have to use algebra. Okay? So, what we'll do first of all, let's do one that we know the answer to already. Let's do that 0.3 recurring one. Now we know, don't we, that that is going to be a third. We know that 0.33333 is a third. What we're going to do now is we're going to prove why it's a third. Okay, and then you can see how it works with one that you already know, and then we'll move on to ones that you don't know the answer to, and we'll see how that goes. So what you say, you use X or T or M, any pronumeral that you want to, okay? I'm going to say M. And so M is going to equal 0.3 recurring. And now remember, 0.3 recurring means 0.33333, etc., etc. What we need to do then, depending on how many recurring digits there are, you multiply by either 10 or 100 or 1,000 or whatever. So what we're going to do then is we're going to multiply both sides of the equation by 10. So that's going to mean that 10m, because we've multiplied m by 10 as well, is going to equal what?
0.
Ah, well done. 3.3 recurring, isn't it? Because remember here, all we've done is we've multiplied by 10, so it's gone there. So it's 3.3333. It's not 0.33333 anymore, it's 3.333. And if we multiplied it by 100, it would have been 33.33333, which is the percentage, isn't it? Okay, Now this is where it gets slightly tricky. You just need to think it through. If that is 10m, so what I'm going to do now is I'm going to do 10m subtract m. So 10m is 3.3 recurring, m is 0.3 recurring. What is then 10m take n? It's algebraically, what is it? It's 9m. Okay, and what's this? 3. Okay, so now what we can say is that 9m equals 3. This bit here is just to show you the explanation. So you start with m, you multiply by 10, 3.3 recurring, and then what we're going to do is we're going to we want to get rid of the recurring bit, don't we? We need to get rid of that recurring bit and make it an integer. So we do 10m take m, which leaves us with 9m, and then if you put if you substitute those values into it, 10m is 3.3 recurring, m is 0.3 recurring, so our answer is 3. So therefore, 9m equals 3. Is everyone with me? Okay. How do I find out what m is now? What do I do to that equation? We did this last year. How will I find out what 1m is? Divide by 9. So n is the fraction, equals 3 divided by 9. And what is the simplified form? 1/3. So 0.333 recurring is 1/3, which we knew that proves it, okay? Now, when I did this last year with my other class, for about 3 examples, I had people looking at me as if to say, are you actually speaking in English, Mrs. Richmond? This is probably one of the trickiest things we'll have done so far this year, because it involves a conceptual thing about the actual recurring decimals, but it also involves rearranging equations to solve them. So we're going to do a few more, and just then what I want you to take note of in your own head is which example did the penny drop? Was it the second example, or the third example, or the fourth example? Don't expect to always understand it the first time. This is what you will find, and I said this to you at the beginning of the year, that you will have times when you do not understand it. You will, because that's the nature of harder maths. And you have to get used to that feeling. It's not nice, is it? When you don't understand it, I know exactly, I don't like it either. It's called disequilibrium, so you don't enjoy it. But what you've got to do is get used to that thought and just keep listening, and then I'll just be interested to know when the penny drops for you. So we're going to do another one now then. So we've just done 0.3, so now we're going to do 0.4 recurring. So let's assume that m, again, is 0.4 recurring. What will 10m be?
4.4.
4.4 recurring, yeah. 4.4 recurring. Now we need then to do 10m subtract m so we can find out what 9m is. What's 10m subtract n?
9m.
Yeah, it's 9m. What is 10m then? What value do I need to put in there? 4.4 recurring. M is 0.4 recurring. So if I do 4.4, take away 0.4, what am I left with? 4, exactly. So we know then, don't we, that 9m is worth 4. Now, for us to find out what 1m is, then, we divide both sides of the fraction by, by 9. So m is equal to 4/9. Now, if you on your calculator now do 4 divided by 9, your answer should be 0.4 recurring. Yes?
Yeah.
Good. Okay. Pennies dropping anywhere? Okay, good. Let's do one more like this. So, 0.7 recurring. So we're going to do ones with just one digit at the moment, then we're going to move on to ones with 2. So 0.7. M is going to be equal to what? 0.7 recurring. What will 10m be worth?
7.7.
Yep, 7.7 recurring. So what will 9m be worth? 7. Because it's that one, subtract that one. And so m is going to be worth 7/9.
You not get where the 9 comes from?
Because,
I know if you minus the where's the 9 come from?
right, if you've got 9m, what that literally means is 9 times m, doesn't it? Do you remember? Multiplication is the default sign for algebra. So if 9m equals 7, remember when we do it, we do the inverse. Stop talking, please. We do the inverse. So the inverse of multiplication is division. So we divide both sides by 9, so m is going to equal 7/9. Okay? Right, let's try one more.
This will everything be over 9. Wait, will everything ever be over 9?
No. No, this next one won't be over 9.
Because it's 0.7.
Right. This time, we're going to have the recurring decimal 0.24. Now, 0.24 means it's 0.24242424, etc. Okay? This time I'm going to use a different letter. I'm going to use T, as it doesn't matter what the premium rule is. So T is going to equal 0.24 recurring. Now, what do I need to multiply both sides by? Think about this. Noreen?
100.
Well done, 100. So we're going to multiply this side by 100, so it's 100t. And then this side multiplied by 100 is going to be 24.24 recurring. Now then, we need to then do 100t subtract t. So it's 24.24 recurring, subtract 0.24 recurring. What does that leave us with?
24.
99t is equal to 24. So how do I now find out what t is?
24.
24 over 99.
Simplifies to 8 over 3.
8.
8 over 33.
8 over 33. Okay, stop now then.
I'm very happy now I get it.